All right, so this is definitely a harder problem, but it's a good challenge. So we're going to still use the same idea. The difference here, the challenge is just setting up the equation properly. Okay, so we're talking in this question about traveling. We have 1,344 miles, and on the way out, the wind is pushing you, and on the way back, you're slower. The trip back took 8 hours because the wind is in your face, or in this case, the plane's face. Okay, so the equation that you might recognize from this, and it's a equation that's used commonly in physics, is distance, which stands for d, equals rate times time. Distance equals rate times time. Really simple example of this. Suppose I ask you how far are you traveling if you go 60 miles an hour for 2 hours. 60 miles an hour, that's your rate, and 2 hours is your time. And you could probably tell me if I go 2 hours at 60 miles an hour, that's 120 miles. Okay, that's an example of distance, which is 120 equals rate times time. So that's what we'll do right here. So again, we need two equations and we need to identify our variables. And they're telling us find the speed of the plane. So we'll call speed S. And actually, I shouldn't call it S because we're talking about speed here. Let's call it P for speed of the plane. And speed of the wind, we'll call that W. Okay, and we're going to use this equation, distance equals rate times time. So a plane traveled 1,344 miles each way. So that means the first trip was 1,344 miles. That's our distance. And that's going to equal rate times time. Okay, we don't know the rate, but we know that the trip going out was with the wind. So that means the speed of the plane was being added to the speed of the wind. Right? The wind is pushing the plane. So that means this number should be increased in its speed. And we know the time took 7 hours. So let's just simplify that. 1344. If we distribute the 7 right here, we would get 7p plus 7w. Okay, we know that the trip back also took the same distance. Obviously, it was a round trip. Okay, and we know that in this case, the plane was having the wind subtracting from its speed. The wind was pushing against it. It says the trip back was into the wind. You probably experienced this. Have you ever gone bicycling or running with the wind versus against the wind? Obviously, if the wind is pushing you, go faster. And then that took a time of 8 hours. So let's distribute the 8, and we would get these two equations right here. Okay, the hardest part of that problem was definitely setting up the equation correctly because it's not obvious how to do that. But the more practice you have with these and more experience, the easier that will be. Okay, now we need to decide whether to solve by elimination or substitution. And let's just do substitution. We haven't done that in a while, so just to vary it up. Okay, so let's decide, it doesn't really matter. Let's substitute for P right here. So we'll do that by subtracting 7W from both sides. So we get 1344 minus 7W equals 7P. And how do we solve for P? We could divide by 7. So when we do that, we would end up with P equals 1344 divided by 7. I believe that's 192. Let me just double check here. 700 plus 6. Yeah, that's 192. And then 7W divided by 7 is that. Okay, so there we have this. Now we can go to our second equation right here. Use a different color there so it doesn't throw us off. We'll go to our second equation. 1344 equals 8 times P. But we know that P is equal to this thing because we just solved for it. So we'll plug that in right there. And then we have minus 8W. Okay, now we can solve this. So 8 times, that's going to be 8W. And then, sorry, 8 times 192 is going to be 800 plus 736 is 15. Sorry, that's becoming a mess there. Let me erase that. 1536. Okay, so all we're doing is distributing that 8 right there, and we get 1536, and that's still equal to 1344. Okay, now we can start to clean this up. So 1344 equals 1536 minus 8W minus another 8W is minus 16W. Okay, now we can subtract 1536 from both sides so that we can isolate the 16W. Okay, and that's going to turn out to be negative 192. And then we solve for W by dividing by negative 16. Negative 192 divided by negative 16 is 12. So that means the wind is pushing the plane at 12 miles an hour. Okay, now we need to solve for how fast the plane is going. So we'll solve for the plane speed, and it doesn't matter which one we use. Let's just use this top one right here. 1344 equals 7 times the plane speed. We don't know that, but we do know that W, I'm plugging in 12 right there. Okay, so 7p plus 7 times 12 is 84. And then we will subtract 84 from both sides. 1260 equals 7p. If we divide both sides by 7, we would get p is equal to 180 miles an hour. So not a very fast moving plane, but that's okay. It makes sense that the plane is going pretty quick if it's covering 1,300 miles in only 7 hours. So that's how you would set up an equation like that. Definitely more of a challenge, but hopefully the procedure made sense.